Hi students, welcome to the video lecture 1 on the topic fluid dynamics, which is taken from module 3. So in the previous classes we have studied fluid kinematics. So in the today's class we will study the fluid dynamics. So what do you mean by fluid dynamics? The study of fluids in motion where pressure forces are considered, it is called as the fluid dynamics. So in the previous fluid class, that is fluid kinematics, we have not considered the pressure forces. But here in the fluid dynamics, the study of fluids in motion where pressure forces are considered, it is called as the fluid dynamics. And next, we are going to study here the forces acting on the fluids in the motion, and we are also going to study what we mean by equations of motion. Here, in this fluid dynamics, the dynamic behavior of the fluids in motion is analyzed by the Newton's second law of motion. And here we have assumed the fluid is assumed as incompressible fluid and it is non-viscous. So here we will study what are the different forces acting on the fluids in motion and as well as the equations of motion. So according to Newton's second law of motion, the net force Fx acting on a fluid element in the direction of x must be equal to the mass of the fluid in the element into acceleration in the direction of x. So how we'll write this mathematically? Newton's second law of motion, mathematically we'll write this as F is equals to m into a, where this x indicates direction. It is Fx is equals to m into ax means where a is acceleration and x is the direction. It is Fx is equals to m into ax. So the following forces are present in the fluid flow. So one is that is Fg, that is gravity force. Fp, it indicates pressure force. Fv, it indicates force due to viscosity. Ft, it indicates force due to turbulence, whereas Fc, it indicates force due to compressibility. So all these forces, gravity force, pressure force, viscosity force, turbulence force, compressibility force, all these forces are present in this fluid flow. So how we'll write this net force now, where Fx indicates the net force, Fx. So how we'll write Fx net force? So this net force F of x, it is the addition of all these forces, that is Fg of x plus Fp of x plus Fv of x plus Ft of x, that is Fc of, that is gravity force plus pressure force plus force due to viscosity plus force due to turbulence plus force due to compressibility. So all these x indicates the direction. So this equation, it is called as the equations of the motion. This entire equation, it is called as the equations of the motion. Now in this equations of motion, if the force due to compressibility, that is Fc, if the force due to compressibility, this Fc is negligible, then my equation reduces to, if this is negligible, then my equation reduces to F of x is equals to Fg of x plus Fp of x plus Fv of x plus Ft of x, and then this equation, this is called as the Reynolds equation of motion. Reynolds equation of motion. So in this equation, if the force due to turbulence is negligible, then my equation reduces to F of x will be equals to Fg of x plus Fp of x plus Fv of x. Then this equation, it is called as the Navier-Stokes equation. This Navier-Stokes equation, if the fluid is assumed as ideal fluid, or if the force uh, due to viscosity is negligible, whereas ideal fluid is a fluid which is having zero viscosity. That means if the viscosity is negligible, that is Fv is negligible, then my equation reduces to f of x will be equals to fg of x plus fp of x. So this equation, that is where gravity forces and where pressure forces are only considered, then that equation it is called as the Euler's equation of motion. This equation it is called as the Euler's equation of